The mean, technically the arithmetic mean, treats every data point in the set with equal weight. But what if some of your data points are weighted more heavily than others? Then you use the weighted mean, and we're going to talk about that right now. Welcome to Math Bytes, I'm Allison, and today we're talking about the weighted mean. Suppose in a particular class, 3 scores contribute to your final score. You have a homework score, a midterm score, and a final score. And each one of these contributes equally to your final score. They're all worth the same amount. Well, then to find your final score in the class, we could just take the mean of these scores. So we would have x bar is equal to 80 plus 85 plus 75 divided by 3, because we have 3 scores. That's equal to 240 over 3, which is equal to 80. Now suppose you have the same scores for your homework, midterm, and final, but they're weighted differently. Your homework is worth 40% of your grade. Your midterm is worth 25%, and your final is worth 35%. Now how do you calculate your final score? For that, you need a weighted mean. Okay, so let's take a look at the formula for the weighted mean. And we'll just call it x bar w to distinguish it from our x bar, our usual arithmetic mean. It's equal to the summation for I equal 1 to n of wi times xi divided by the summation for I equal 1 to n of wi. And you will see that shorthanded this way, the summation wixi over summation wi. Okay, so now what does this mean? On the top, it means we take each data point, multiply it by its weight, and then add it to the next data point multiplied by its weight. So that gives us on the top w1 times x1 plus w2 times x2 plus w3 times x3, so on and so forth, plus wn times xn. And on the bottom, it simply means that we add up weight 1, weight 2, weight 3, etc. So on the bottom, we would get w1 plus w2 plus w3, etc. plus wn. Okay, so let's go back to our example of scores in a particular class and find the weighted mean. So we have our homework score is 80 and worth 40%. Our midterm score is 85 and worth 25%. And our final score is 75 and worth 35%. All right, so our weighted mean will be the first weight times the first score, 0.4 times 80, plus the second weight times the second score, 0.25 times 85, plus the third weight times the third score, 0.35 times 75, all over the sum of our weights. So over 0.4 plus 0.25 plus 0.35. Okay, so on the top we get 32 plus 21.25 plus 26.25 all over 1. And that turns out to be 79.5. So you can see that with our scores weighted this way, our ending score is slightly less than it was when these scores were weighted evenly. And that makes sense if you look at that. Our midterm score is higher, but in this case worth less. And our final score is lower, but in this case it's worth more. Okay, let's do one more example of finding the weighted mean. We did a little survey of the number of pets in various households and came up with this data. The number of households with no pets is 37. The number of households with 1 pet is 51. The number of households with 2 pets is 42. The number of households with 3 pets is 29. And the number of households with 4 pets is 11. So let's find the mean, in this case, the weighted mean. So remember, we're just going to take the weight of each data point multiplied by that data point, add them up, and divide that by the sum of all our weights. So we get 37 times 0 plus 51 times 1 plus 42 times 2 plus 29 times 3 plus 11 times 4. And that's all over the sum of all our weights. So 37 plus 51 plus 42 plus 29 plus 11. On the top, we get 0 plus 51 plus 84 plus 87 plus 44 all over 170. And that gives us 266 over 170, which is approximately, rounded off, equal to 1.57 pets per household. Now, we found that our weighted mean was 1.57, which is not a whole number, and obviously pets come in whole numbers. Somebody doesn't have 1.57 pets in their house. But because this is a statistical measurement, it does not have to be a whole number, even though the things that we're measuring come in whole numbers. The weighted mean is really not that complicated. It makes sense when you think about it. You take the weight of each data point multiplied by that data point, add it up, and divide it by the sum of all the weights. Don't let the notation fool you. The notation looks complicated the first time you see it with the summation signs and the indices. It's still a fairly simple calculation, so get used to the notation and don't let it get in your way. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.